Hey guys, today we are going to discuss this problem. We are going to start with the example here. So in the input, we are going to have a number which indicates how many test cases are there in this problem, right? There are 5 test cases. And for each test case, we are going to have a string as the input, and we are going to output a string as the result, right? And for the given string, we're going to construct the output string. And the output string must satisfy 3 conditions. The first condition is that the output string is constructed by the prefix of the input and the suffix of the input. For example, this guy is constructed by the prefix of this guy and the suffix of this guy, right? This part equals to the prefix and this part equals to the suffix, right? This is the first condition. The second condition is that this string must be palindrome. That means if we reverse this string, it must be the same as this string, right? Let's reverse it, right? A, B, C, D, F, D, C, B, A, right? This two stream is exactly the same, so we call it a palindrome. That is the second condition. And the third condition is that we must make sure that this is the longest stream that satisfies the previous two conditions, right? The third condition is that this guy must be the longest, right? How do we solve this problem? Um, I'll put the solution here. This is the algorithm. So we're going to go through this step by step, all right? So the first step is we translate it into the math problem, right? Let's take this example here. So this is just a bigger version of this string, right? So first, we translate the problem into find a t that can be modeled as this guy, right? So we have string s is the given string. And 1 to L, we're going to find L and R here. So in this case, we can find L equals to 1, 2, 3, 4, 5, 6. This 6 is L. And R equals to 3, right? So the T looks like this, right? 1 to L, and N minus R plus 1 to N, which is this part, right? And the T is equal to the sum of these two parts, right? And for some number L and R such that their rho is less or equal than L and R, this is obvious, right? Because these two pointers must be inside this string, right? And L plus R less or equal than N. This is also obvious because L is smaller than R, so the sum of these two numbers is less than or equal than N, right? This two is obvious. And let's find the maximal integer that k such that one s1 equals to n and s2 equals to n plus n minus 1. So what is the k here? So k is the maximum number that makes the um, prefix reverse equals to the suffix, right? So we can find that k here equals to 3, where this guy equals to this guy equals to this guy equals to this guy, right? Which is this condition, right? So prefix reverse equals to the suffix. And in some optimal solution where t is as long as possible, and mean value of L and R equals to K. Why is that? For example, in this case, R equals to 3 and L equals to 6, right? K here equals to 3. So obviously, our example here satisfy this condition, right? Because mean of 6 and 3 equals to 3, right? And how about the other cases? Like in this case, we can also make L equals to 6, right? And R equals to 2. In this case, this guy plus this guy is still equal to this guy, right? T equals to the sum of these two streams, which means we can find another set of L and R satisfy this condition, right? So it looks like it contradicts this condition here because the mean number of L and R equals to 2, and 2 is less than K, right? So what happened to this example here? So in this example, because we already know that this guy is equal to this guy, right? So that we can just decrease. We can just decrease L here, make it actually the L here equals to 7, right? So we can decrease the L here by 1 so that the new L equals to 6, and the new R, we can increase the R by 1 so that the new R equals to 3, right? Because we can make sure of that this guy is equal to this guy so that we can just increase the R and decrease the L, right? So that we can still have this condition met, right? So with that being said, we can know that if we want to find such a t, we can just first find the longest k, right? And then we break this stream into 3 parts: the prefix, the suffix, and the middle part, right? And we already know that the reverse of a prefix equals to the suffix. So if we can find a prefix of the middle part, which is also a palindrome, Then let's say this palindrome equals to, let's take a variable, like let's say this palindrome equals to W, right? Then this part plus the W and plus the suffix must be a palindrome. Why? Because this part's reverse equals to this part, and this part is a palindrome, right? So we can make sure that the sum of these three parts is a palindrome, which satisfies the initial condition given by our problem, right? So we translated this problem into find the longest prefix in this middle part that is also a palindrome, right? And also another option is that we find a suffix in this middle part, which is also a palindrome, right? Let's say the longest suffix, palindrome suffix is E here, right? So we add these three parts together, which is A, B, C, E, C, B, A. This guy is also a palindrome, right? But it is a shorter palindrome, so it is not the final output, right? So in other words, we can find the longest prefix palindrome for the middle part, which is DFD, and we can compare DFD with E, and we are going to choose the longer one and add them together to get the final answer, which is this guy, right? Cool. So if we know that mean value of L and R equals to K, we just need to find the longest palindrome W, that is prefix or suffix of the string, right? After that, the answer will be the first part plus the longest palindrome and plus the last part, right? So that's it. In order to find the longest palindrome, which is a suffix, which is a prefix of some string A, let's find the P from the prefix function of the string A plus number sign plus reverse of A, where reverse of A represents the reverse of A. The string This string will be the longest palindrome, which is the prefix of A, right? So in other words, this step tell us we need to use prefix function to find the longest palindrome in the prefix of this string, right? So what is the prefix function? We will explain that in a minute. So what is the prefix function? So prefix function equals to LPS, right? So what is LPS? LPS is the longest proper prefix, which is also suffix. Longest prefix, which is also suffix, right? For AAA here, the LPS array is like this. Why? So for let's take a look at A itself. So LP for A, the longest prefix, which is also suffix, is 0. It is a constant value for the first LPS, right? And for AA, the longest prefix, which is also suffix, is A, right? Which length is 1, right? And what about AAA, right? AAA's longest prefix, which is also suffix, is AA, which length is 2, right? That is boring. Let's take another example here. No, let's take another example here. So for this string, the first LPS is 0, and the for AA is 1, right? Because A equals to A. And for AAB, we cannot find anything. The prefix cannot be equal to the suffix, right? For AABA, for this string, A equals to A, right? So the prefix is A, the suffix A, they equal to each other, so the length is 1. And what about AABAA, right? So the prefix is AA, the suffix is AA, they equal to each other, and the length equals to 2, right? What about this guy, AABAAC, right? The prefix cannot be equal to the suffix, so it's 0. And for this guy, the prefix is A, the suffix is A, so the length is 1. For this guy, the prefix is AA, the suffix is AA, so they equal to each other, the length is 2. For this guy, the prefix is AAB, the suffix is AAB, they equal to each other, and the length is 3, right? For this guy, the suffix is AABA, the prefix is AABA, so they equal to each other, and the length is 4. So as the last one, the suffix is AABAA, the prefix is AABAA, they equal to each other, and the length is 5. All right. So I guess that explains how we calculate the LPS. So with the LPS, how are we going to find the longest palindrome, which is a prefix? So I'll explain that. So let's still use this example, right? Because our goal is to find the palindrome, which is also a prefix for this string, right? So as it says, we are going to construct a new string. Looks like this, right? This is the first part, and a number sign, and the reverse of the first part. E, C, D, F, D, right? And we are going to calculate the prefix function, which is also the LPS, right? 0, 0, 1, D equals to D, right? 0, 0, 0, 0, 0, 1, D equals to D, right? 2, DF equals to DF. 3, DFD equals to DFD, right? So with the prefix function, we can see that the LPS of the last value is 3. So we can be sure that this guy, this string equals to this string, right? So uh, with this being said, why can we be sure that this string is a palindrome? How can we make sure of that? That is because this string is the reverse of this string. So for our goal is to prove that this is a palindrome, which means this guy should be equal to this guy, right? So how can we prove that? Because this string's reverse equals to this string. So this guy must equal to this guy, right? Because it's a reverse. And we know that the prefix function of this value equals to 3, so that we can be sure that this guy equals to this guy, right? Because the third character of the prefix is D, right? And so this guy equals to this guy, and this guy equals to this guy. So this guy equals to this guy, which proves that this is a palindrome, right? So we can be sure that this uh, way to calculate the prefix palindrome is valid, right? So with that being said, we already find the palindrome in the prefix. We can repeat this process for to find the longest palindrome in the suffix, right? And we can compare the length of those two palindromes and choose the longer one as the middle part, right? And output the answer, right? So that's how we solve this problem. And let's take a look at the code. So first, we are going to uh, read the number of test cases and solve each one of them, right? Let's remove the C out here. This is only for me to debug. And we read the S here, and the length of the S is N, right? And we are going to calculate the biggest K here, right? So we are going to have 2 pointers, one pointer to the start and the other point to the end. And if they're the same, we just increase the first pointer and decrease the second pointer. And uh, this is how we did it. And with the K here, we are going to get the W, right? Um, so actually here we are going in this code, the W is the middle part, right? The W is not exactly the same as the W in the algorithm explanation here, right? So just call that out uh, in case of confusion, right? And then we are going to create the string for the prefix calculation, right? And we have a small function here, which is to calculate the reverse of a string, right? And then we are going to use this function to calculate the longest palindrome of a string, right? So this function calculates the longest palindrome in the prefix, right? And here is how we calculate the LPS. it's a template code. You can just copy paste every time you want to calculate the LPS, right? And the time complexity of this algorithm is O(n), all right? And we are going to return the last LPS value, right? And we are going to uh, repeat this process to this stream as well, so that we can get the longest palindrome of the suffix, right? We need to calculate both prefix and suffix for the middle part. And then we're going to choose a longer one and output it in the end, right? So that's it. Thank you for watching.